Thank you, Lisa, for the kind introduction and, of course, for hosting the AI Science Café series here at the Royal Institution. It's a real honor for us. I'm from the Czech Center. Just a sentence. The Czech Center, we tend to promote the mutual ties and foster the ties between the UK and the Czech Republic in a number of areas, in innovation, science, but also culture and art. And it seems that day after tomorrow, we might have some more jobs to do. So we're rolling up our sleeves. You might be asking why we do the AI, why we're dedicating the entire series to the artificial intelligence. In particular, the AI, not a long time ago, has not really been a topic on the radar of many companies or government institutions, nor the individuals. But the situation today is very different, and I think 5-10 years from now will be dramatically different, even from today. Over the last year, the AI really evolved from the popularizing realm of the chess game, been beating the best chess players, it's been composing the classical music, which the score is not really, cannot see the difference from the masterpiece. It does also the modern conceptual art with full of expressions and emotion. And I feel it's just the beginning. I think many of us are using the smart devices full with the social media, social networks, different applications. And the transactional data and informations are being processed with algorithms that have unparalleled capability to store and analyze our data, which are not comparable with the human brains. There have been a number of studies and analysis being performed, and it proved that the computer algorithms from companies like Facebook, Google, the Microsoft, Cortana, Apple, Siri, everyone knows, are a better judge of human decision and predict much more accurately the actions that we as a people do today. There is an indisputable trend that many people give up their privacy and individuality to conducting much of their lives online. Having said that, the subject of cybersecurity and personal privacy is of eminent importance. And I'm very pleased that we have here this evening one of the great experts in the area of cybersecurity and privacy, Professor Michal Pěchouček. Michal, just a brief introduction. He's a lecturer professor at the Czech Technical University. He's also a founder of the AI Center in Prague, a successful entrepreneur. But fairly recently, he also became a chief technology officer at the leading antivirus company, Avast. Before I turn the floor to Michal, I want to just say last information that after the presentation, there will be a dialogue and a QA with Michal, which will be led and chaired by Professor Michael Luck, who is another esteemed expert on the AI. He's also the executive dean of the faculty, natural and mathematical sciences at the King's College here in London. So without any further ado, I would like to turn the floor now to Mike, and I wish you have an inspirational evening. Thank you.
Thank you very much. So thank you. I'm really pleased, honored. It is emotional because, 25 years ago, I got my degree in AI from Edinburgh. So I'm kind of coming back and sharing my learnings, not from my studies, but from those 25 years when I practice AI, and I would like to share that with you. Even though I'm currently tech executive at Avast, in heart, in soul, I'm still an academic, which you will see through the slides. Whenever the academics is given the opportunity to speak, he prepares twice as many slides, right? So I cannot plan for 60 minutes, so I'll be flying over similar to as all the other professors are doing. So you will see the drill. So Before I'll do this, I want kind of to explicate the takeaway, right? So I'll be speaking about security and about this like very important aspect of security, which is cybersecurity. And I'll try to explain to you the links between AI and cybersecurity, why it's important and why it's hard, right? So if you guys lead this lecture, this debate with the takeaway that you know that it's important and then you understand why it's hard, I'll be really pleased. So I'll be speaking not only about kind of my ideas and my work, but I'll be also speaking about the work of many of my colleagues. A few of those are listed here. So why AI is so successful today, right? So people have many definitions, right? So I will simplify my definition that I like to work from is that AI is a scientific field and a set of technologies that are here for us to be able to replicate or improve or accelerate or make more precise human cognitive capability. And by human cognitive capabilities, I mean reasoning, decision-making, and perception, right? So those kind of three important things that people are doing, AI is trying to kind of build in programs. And coincidentally, those human capabilities are very much connected to how people are earning money. That's very much related, right? So that's often our work based on what we see, how we reason, how we plan, how we decide to make actions, how we work with numbers, how we predict. And AI, because of its recent advancements, is capable of kind of doing lots of this work for us, and it's kind of dipping in our job market. So, and we all see that, and this is kind of a big change. And when people ask me what is going to be the big piece in 2030, whether it's going to be an intelligent toilet, I say no, it will be jobs, right? And we kind of all know this. Cybersecurity as a field is, believe it or not, it's function of people. There are defenders and there are attackers and there are people, right? However, this whole ecosystem of attacks is big and vast, and it's getting to be fairly automated, right? So we are seeing like lots of automation happening on the side of the attackers as much as on the side of the defenders. And this is what I want to speak about. Just to give you a bit of context, AI is successful because it's bringing money. So unlike in 90s, where we did this great, there was AI winter, right? But there were great papers written on AI 25 years ago that are pretty much like the foundations of current applications. But these days AI is important because it's now turning the results into applications. And there are actually three families of applications that I would like to kind of emphasize. One is AI for business, kind of AI being in e-commerce, in industry, in transportation, and kind of making our life easier, therefore making money and selling the service and the capability. So this AI all around us, this is like this big application field. There is the newly emerging application field, which is AI for social good, right? So there's a lot these days that we see happening in AI in climate, AI for wildlife, AI for diet and healthcare. Well, healthcare is still business. AI for poverty. So there are no new applications that we've been seeing only recently, and this is going to be like the new big trends for AI applications. And there's a third one, which is somewhere in between. And it's AI for citizen safety and security. It's an important piece. It's business, right? So people pay for security, but at the same time, it's vital for how our society is structured and organized. And this is the field of application which interests me and where I've been spending my professional career. So, and now, why the time is ripe now to really talk about AI and cybersecurity? For one, because nobody actually cracked it, right? So we are seeing those great results with DeepMind that are able to predict a glaucoma 10 years ago from the retina scan. That's a big result. That's impressive moonshot. So we see impressive moonshots in transportation and in other fields. We haven't seen an impressive AI moonshot in the field of cybersecurity as of yet. Why is that? A couple of reasons, right? The reason number one is that it's hard. The subject matter expertise of understanding the internet traffic And being able to split the good internet traffic from malware is non-trivial. You need good education and years of practice to be able to do this. It's not like being able to distinguish images, koala from monkey, right? So anybody can do this. Doing malware analysis, that's hard. Second one is we don't have data. AI is driven by data, and for lots of applications, data is readily available. For cybersecurity, it's not the case. Companies don't share malware data, cannot share malware data. It's very difficult to kind of come up with like a testing corpora that everybody can use and experiment with, right? So it's the second reason. Third reason is it's just not popular with these scientists. I was looking into how many papers that were written on adversarial machine learning, which is the closest AI field to cybersecurity this year. It was 1,200 papers on adversarial machine learning. It's a huge number, lots of papers, right? You know how many of those were on malware? 36. Only 36 papers were in the field of malware analysis. So people are not excited. And I want to excite you. Who is here who is preparing for his PhD in computer science? Is there any PhD student? Okay, so I may be excited even more that even at a later stage of your career, you can even then try to think about doing a PhD. And the last argument why we are not there yet is that people tend to speak about results. And today I'll be speaking about the work in progress. I will leave the results for the researchers and scientists that work with me to present at conferences, but today I'll be more visionary and I'll be speaking about the work in progress, right? So I haven't given this talk before, right? It's my kind of freshly baked content. So now comes acceleration, right? So I'll do this slightly faster. So why people bother writing malware? Why it's so important and exciting? So it's a business, right? People do this because they are building and selling botnets on the market. People are building and selling ransomware that is encrypting your hard drive, and then they are asking you for ransom to be given back the data. People write malware to steal private data, right? To steal valuable documents. People write malware to launch DDoS attacks. And often people write malware to create spams. So often malware is aggregated, must be spread wide to be able to collect the revenue, right? If there is too little revenue with malware and it's too expensive to write it, people don't do this. It's like very economical thing. So one of the approaches that the cybersecurity experts are taking is trying to make the malware writing process expensive. So that it's not worthy to do this. Unfortunately, the truth is the opposite, that AI is making the malware process writing cheaper than any time before. So I give you like a peek view into antivirus engine. What is it is happening? It's not one program, it's a series of programs doing different things and pretty much kind of taking internet traffic in, taking the files that are being sent across the network in, and telling the verdict on each of the files, whether it's clean or whether it's malicious, right? And there are different phases of the analysis that any antivirus system is doing. So one is like checking on the web whether the file came from like a malicious address, like very simple. So then there is a next layer where the file is being kind of reconstructed and analyzed syntactically, whether there are some flags that may suggest that it's malware. Often it's not the case because the malware is packed in some packer. So then people are running the piece of file in some sandbox, in some virtual environment to see what is it's doing, whether it's sending somewhere something or not, right? So there are like lots of experiments that are done in real time while the internet traffic is going. And many of those slides these days are AI enabled. So there are AI algorithms, there are lots of classifiers, anomaly detectors, lots of AI programs that are making it possible for us to crunch through this huge volume of data. Just to give you the idea, so that you know this, the volume, Avast sees every day, Avast blocks every day 50 million of attacks, right? 50 million attacks every single day. Avast sees every single day 1 million new files that we haven't seen before, 1 million. Out of this, couple of hundreds thousand are new malware that we haven't seen before. To kind of give you the scale, how busy we are, right? We have 420 million users, right? You know how many people? I cannot say how many people, but it's small number of people is checking the traffic, and it's possible only because all those slices are AI enabled. Lots of the analytical work is automated. Lots of it is done automatically, and those analysts that are working in the company are only working on those most complicated and interesting attacks. So I'll accelerate even more. I just give you this idea. It is one piece of malware that we saw changing in 7 days. And each time the system identified why it's malware. And these are the arguments. These are the strings that were found in the malware, which was the same piece of malware, but it was changing polymorphically, automatically, and the system find the argument, the trigger condition why this particular piece is malware. Okay, so I'll try to speed up a bit. So people often ask me whether the attackers on the other side, the bad guys, whether they are using AI, right? Is it so? Are we in AI against AI world currently? I told you that we are not, because we have attackers, defenders, all paraprofessionals, AI empowered. And the attackers are using AI for a number of reasons, right? So currently we see attackers using AI for creating a misleading content. So lots of content that is being created and propagated online currently is AI created. So AI is used successfully for building a sophisticated phishing attacks. So the more the internet knows about you, the more private data you disclose and share on social networks, and the attackers have an access to, they can use AI to understand and build your behavioral profile. They can predict what you like, where you show, what you want to do. And having this model, they can script much more believable phishing attacks, right? That can tell you, you have to click here because we know you very, very well, right? Only my mother knows me this well. So, and this is the argument why people click, right? So a lot of AI is using for building a sophisticated, believable phishing email these days. So people have experimented with using AI for cracking Wi-Fi access very successfully. People use AI for building spam engines. IBM have recently announced that they have built what they called a deep locker, which is a piece of malware that is having the trigger conditions, the if-then rules that tell the program when it's supposed to attack. It is embedded in a neural network, which is very difficult to reconstruct. Nobody understands it. Hence, this piece of malware is undetectable, and IBM were able to show that this is possible. So lots of cool stuff is happening on the attacker side. So the bad news is that the defenders are just one step behind the attackers. The whole field, the whole cybersecurity business is very reactive, actually, because we are building new tools and new programs to detect malware that we see, right? We rarely build a capability that is predictive, that is able to predict malware that will be here with us in the future. So it's very reactive business. And it's also slow because there are only tens of the analysts. Now here's the number that I wasn't able to, that I shouldn't tell you. So it's tens of analysts are trying to analyze malware that was written by thousands of malware programmers. And also it is very brittle. because the detection is able to see only some malware samples, and the trivial modification of the samples is difficult for the antivirus systems to be able to detect. So it's very complicated. So we have ideas, right? So we know what we want to do, right? So we would like to make a foundational, and we are making a foundational AI and computer science progress in two fields that are very topical today. They are on the state of the art of the latest development in AI. One is explainable machine learning, right? Because what we see as a cybersecurity practitioners is that AI and machine learning is fairly successful in detecting malware, but the analysts don't believe it. The analysts that get their own eyes, it's like doctors, right? Doctors are not that great for taking new technology. Security analysts are the same. They understand the world very well, the world of the attackers, and they are not keen to take on new techniques. And for them to use machine learning and AI for analyzing traffic, it's very cumbersome, and they don't want to do this. So we are building a new set of methods that are explainable, where the verdict that the classifier or the detector says about the traffic gives the explanation, explains why the verdict that this piece of file is malicious, it's dangerous, it's lethal, why is it so, right? The explanation piece, nobody is kind of working on this very much in cybersecurity, and this is like a big thing that we want to build, and hence allow the cybersecurity professionals to be more open to AI and machine learning. And the second one is adversarial AI, adversarial machine learning, right? So we see that AI is these days very fragile. It can be misled, right? So we see examples how people can mislead AI. And as I told you, like big part of our engine is AI enabled. So through adversarial samples, we can mislead the antivirus system. So we would like to foster and build our system to be robust against adversarial samples. So to be able to do so, we have a team, right? We have a team that is on a mission towards a non-incremental AI and computer science result, and this team is called Avast ČVUT, Joint Lab for AI and Cybersecurity, which is a joint lab between the university and the antivirus company Avast that has been established 2 years ago. And it puts together like 3 components: the university scientists, the people in threat lab, which are the security analysts lab. Recently, we have expanded this team, and we work with people at UC Berkeley. There is a great research center in adversarial machine learning that became part of the team. We also work with the computer science department at Stanford, and recently we've also included King's College in London, and we have a small contract with the researchers here in London. And this is the structure of the team that is going to work together on this big mission. So the high-level idea, right, for this moonshot is that we would like to be able to create a AI system that is not only servicing like a small slice of the antivirus system. It's modeling the decision making as a whole. It's collecting all the data that we know about the traffic on the internet, all the data that is around the file itself, and we would like to train the system to be able to do the holistic decision and the analysis about what kind of file that is. We would like to be able to construct the explanation, right? So whenever like huge complex neural network tells us that this file is malicious, we would like to build a system that tells me why. Currently, not many people do this, and to kind of really foster here or emphasize the role of the European research. In Europe, we have a tradition of like logic-based AI, knowledge-based AI, reasoning-based AI, which is slightly different to the latest trend in statistical AI. And because there is a tradition and lots of knowledge in this field, I think that Europe is better positioned to make a contribution in this capability, to explain the decision of artificial intelligence. So it's a second big challenge. The third challenge is to understand how is it that the malware writers, how they are changing malware. This lethal piece of code, it's lethal, it's doing something bad, and how do they change it so that it continues to do things wrong, but it's being seen as a legitimate piece of file. This is non-trivial, but people do this, and this is becoming slowly automated. And then, last but not least, we would like to train the classifiers that are robust against such changes of files. So what is it that we want to improve? There is one metrics that we want to improve, and this is the time to detect, right? So malware is created, there is somebody who first executes it. Luckily, somebody from the cybersecurity industry sees it and makes an experiment and analyzes the sample, creates a rule, and then uploads the rule into the antivirus engines. In between, the malware is spread and many users are infected. And if we would be able, with the proper use of AI, to shorten this time, right, this is what we are doing, less and less people will be infected. So this is our objective function. This is what we are trying to do, to make this time as short as possible. So the information that we work with is the statistical information about the file, how it looks like. We can open it and look what is inside. So we have a dynamical understanding of the file. We can test it and see what it does, right? And then we have also the behavioral analysis of the file, therefore what the file is doing with the user, right? So, and this creates like lots of difficult, complicated data. And one of the innovation, the novelty that we were able to do is to be able to represent this complex data in a single format, right? And, you know, web pages are written in HTML, right? So that's the language how we code web pages. And there is a different language which kind of looks like a complex graph-like tree that can encode the knowledge about how bad is the file. And the innovation that we have made is that we were able to show that we can train a classifier which takes the training data not as an image, right? You know, if you take the classifier that tells you that there is a black cat on your image, right? It's simple. You get zillions of images. Here, you've got those files, those tree-like graphs. And we were able to build a machine that is being trained on top of these complex graphs, non-trivial structures. How it differs from classical machine learning, mainly, is that the training examples, the events that you use for training your AI are dissimilar. They don't have the same size, right? Image has got the same size, always, same number of pixels, pretty much, right? Or give or take. Here, based on what is happening on the network, this file is each time different. And like the important AI contribution is to be able to do machine learning on top of these complex files. So we were able to use what we call a multiple instance learning, which is a result of a previous research work that was done in the 90s. Currently, many people use a term deep set for the same concept. And it's actually showing that learning can be done recursively on files that have recursive structure. So I guess I will not go much deeper than that. I will not be explaining to you the exact mechanics, how the neural network is being trained to be able to do this. And instead, I tell you that what we have built is a simple machine that is testing what is the minimal set of the features that are supporting the verdict that the file is malicious, right? And we have a machine that is minimizing the examples and trying to find the minimal working example that is still telling the engine that the file is malicious. And this is a structure for explanation. And this explanation is being provided to the analysts. So I guess I'll skip this piece and speak very briefly about adversarial attacks. So the other challenge that we are working on is to make sure that the AV engine is not is robust against adversarial examples. What happened to Avast many years ago was that there is a competing company in cybersecurity, and they, for some reason, they knew that we are like really good in trying to detect a Trojan, right? Trojan malware. And they were able to reverse engineer the algorithm that did that. Once they were able to do this, they were sending on the internet files that we classified as Trojan, but they were legitimate. They were able to deceive the system because they knew how the algorithm works. And through doing that, they were harming our efficiency. So then in tests, our engine didn't work that well because it was claiming files that were artificially engineered to look like malware, but not big malware. So they sent those files. They were not doing any harm. They only deceived our system. So it's as an example of an adversarial sample. These days, you all know those adversarial examples that people use in computer vision, right? You all saw those images that look like for a human being as a stop sign, and the camera reads them as a speed limit, right? You can engineer an image that the camera thinks it's a speed limit, but it's stop sign, right? And these are kind of carefully crafted samples of data that are deceiving the algorithm. And these cybersecurity professionals on the attacker side, they are doing exactly the same thing. They are kind of crafting files that look like legitimate, but they are malicious. How they do this? They are modifying malware. They are putting like a legitimate piece of code to malware to look like legitimate. A nice example is a Microsoft software license. It's a piece of file that if you kind of add it to malware, it looks like Microsoft something, right? So then, like in the past, lots of engines saw, okay, this is Microsoft something, let us beat it, right? There was this mix of piece of benign, legitimate piece of program with something like really lethal. And this mixture of things, this is piece of art, right? And these days, to be able to deceive the anti-malware systems efficiently, this mixture is being done through computer science and AI. So how you can avoid adversarial attacks in your defense system? You can do this by retraining, right? So you still retrain, you retrain and retrain so that your system is it learns all the possible changes that can happen in your code, right? If you do this, the cost is that the efficiency of the decisions is being reduced, right? So you got this trade-off, how predictive you can be, how many more future pieces of malware you want to include in the capability, versus how precise and exact you are against the current attacks. It's non-trivial. And we were able to solve this by modeling the interaction between the defenders and attackers as a multi-party game. It actually is a multi-party game. There are like two teams, blue team, red team, and they are kind of fighting against each other. Because in our team, there are experts in game theory, people who build deep stack. You know deep stack? Deep stack is the poker bot, best in the world that first was better than a human player, built at the University of Alberta by a team led by Mike Boeing. And a few people from this team are now working with us in Avast and are trying to model the interaction between the attackers and defenders as a game. And there are kind of actions that each of those players are making. The attackers are trying to modify the malware in the cheapest possible way so that it costs almost nothing. And it increases the likelihood of being undetectable. On the other hand, the AV people, they are trying to tune the parameters of the neural network so that they are not reducing the efficiency, but they are increasing the predictability. So I would I would love to speak more about how this is done. I only tell you that this piece of trying to model the interaction between the attackers and defenders is a blue sky research. There are only a few results being published these days. The latest work that has been applied is the work by Sadia Safros from UC Berkeley, who wrote a monotonic classifiers that have the property of non-reducing the efficacy. And these results have been deployed in Microsoft ATP. So it's now running and it's protecting users of a Microsoft Windows. So without any further ado, I'll just sum up what are the benefits. So this whole research work is, if successful, it brings a couple of benefits to the society. So the one is that it really reduces the time to detect. So the AV engines are much faster, and therefore less people will be affected, fewer infected users. We will be able to improve the benchmarks of the AV engines. It's very important. Second is we can generate high quality labels. Label is a training example. In current AI business, you got a couple of things. One is problems. The other one is the algorithms. And the next one is the training data. And the training data currently is a currency. Many people buy and sell training data. If your developer is building a chatbot, they can download the chatbot from the internet for free. What they need is good quality training data, and these are labels. There's been a startup recently acquired by somebody, by Uber, I know, or by somebody else, and they produce labels for autonomous driving, just feeds from cameras. This is like very, very expensive piece of raw material. We believe if we would be able to produce explanations automatically, that's a raw material, right? So currently, only the expert people have their explanations in their head. But we believe that this piece of research that I just spoke about can generate explanations for why files are lethal automatically, and this data can be provided to others to train their classifiers. And what is the most important result out of this research is that we would improve readiness of the society against future automated attacks that will be more and more driven by AI. So, and I think that with this, I just conclude my introductory remarks, and with great joy ask Professor Luck to be here with me.
Thank you, Michal. That was a fascinating talk, but it was a talk that was, for me, a little complicated.
Oh, Michael.
And so I'd like to just ask you a few questions to explain a few things there. But I'd like to start with a question that my assistant asked me as I told her I was coming here to this discussion today. And I said I was coming to chair a discussion on AI and security. And she said to me a question that sums everything up, really. She said, what about Terminator and Skynet, and how are you going to solve that? So my question to you, which covers everything, is think about the future. Before I get into the details, think about the future. Can you make the world a better place with these technologies? Not necessarily specifically with malware, but in general the technologies, and can you save us from a future in which we have technologies taking over like Skynet from the Terminator films?
So before I go to Skynet and Terminator, I'll tell you about the AI, right? So the AI can make a happier place, because there are many skeptics, especially in California, right, who say that AI will not make a happy place here. And I actually think that it will. I'm an AI optimist. I actually think that with more of AI doing the work for us that we are used to do, and we won't be doing any longer, like the work in banks and even writing software and driving cars perhaps will be free to be more creative, right? There won't be that many jobs that won't be creative, right? So there'll be a push, a requirement for human creativity. And I actually think that this is the foundational argument why I think that we will never become slaves of AI, that AI will not enslave us, because we will be pushed no matter what to be creative, right? Because the work which lots of us is currently doing, which doesn't provide much of a value and maybe even doesn't make any sense, will disappear. So I think that this is why AI will be helpful. In terms of the Skynet, so we will be solving so many more difficult problems in AI and AI safety and security of AI, so that we won't have I don't believe that this ultimate threat of a Skynet will emerge, because on its way we would kind of need to solve much simpler things when it comes to AI and safety, right? So whether AI will be manipulating, I'm okay if AI manipulates what I buy, but I'm not so happy if AI manipulates what I read. So I think people will be first worried about what they read, right? And there'll be lots of regulations coming from the European Union and UK maybe in the use and development of AI and how it can influence our lives. So I'm not worried.
So nothing to be worried about from your AI technologies?
No.
Good. Okay, so let me get down into some of the details then. You talked a lot about explanation, and you said that explanation was a really important part of what you were doing. Can you just say more generally why explanation is so important, not just in the work that you're doing, but in general, and then a little more detail about why it's so relevant to the work that you're doing with security?
Okay, so one can say that explanations are not important. If AI works fine, if it's efficient, precise, fast, it's okay, right? And surprisingly, we are using like lots of non-explainable AI for driving cars, actually, right? So once in a while, somebody gets baked in Tesla, right? But those are just like child illnesses, and we will grow out of this. However, I truly believe that in our society there are tasks that we wouldn't be willing to give away happily to AI unless we fully understand. One example is healthcare. So people would be more careful about decisions being provided by the algorithm if they don't understand. I may be wrong.
So if a machine tells me that I've got some terrible disease, I want to know exactly why I've got that disease, and then I want to know why it's going to be prescribing a particular treatment.
Exactly.
Okay.
And it's not only because I've got this feeling that I want to know, but because human society, mankind, wouldn't be so trustworthy towards this new change. And humans are like really great in regulating themselves. There will be lots of regulation. And no matter whether we like it or not, AI will be regulated. And the explanations will be the mechanism against which often AI will be regulated. It's not only regulation, it's also insurance. Often, insurance is big business, it's part of our lives. And in order to be able to insure something, you need to calculate the risks. And explanations will be one of the contributors to be able to explain the risks and hence being able to insure it.
So how does that relate to the work that you're doing in your systems to develop security solutions? Why is explanation so important there?
So 2 reasons. I'll start with the latter one, which is, in the end, we would want people to take away all the worries about cybersecurity. We just want to tell them, Mike, don't worry, nothing bad happens to you. And if it does, we cover. We would insure you free of charge if you buy our system. In order to be able to do this, I really need to be able to understand what is it that can happen to you and how likely is it. I need to have much more precise argumentation, also computational, to be able to price the risks and to give you such service. And I actually think that this is going to be the future of cybersecurity. Companies will try to take away the worry from people and compensate for the losses. So this is like one important argument why we need explanations. And the second one is to really be able to push automation to the security analysts. These days, they don't trust AI as much as they should. And by providing explanations, I really believe that AI will be more used in the whole sector.
Okay. Can you say why it's difficult to provide those explanations? It sounds like it's a problem, and what are the challenges in doing that?
This is the balance between performance, right, and how more compute you are happy to provide to constructing the explanation. The modern high-performing neural networks, deep networks, machine learning algorithms are known for being super statistical, and if you cut them into pieces, you won't see anything but entropy, right? So they have been designed so. That's a current trend. Even Jeff Hinton, who founded the field of deep networks, suggested that to be able to get more explanations, we need to backtrack and kind of start again from scratch.
So if I understand correctly, what you're saying is we can get to the right answer, we think, but unless we can explain it, we have a problem because we as people want to understand what's going on. And crucially, I think, the current techniques that are being used, deep learning, neural networks, these are techniques that don't naturally lend themselves to providing that explanation. Is that
exactly. These are almost my words.
Okay.
No, nicely put. Thank you, Mike.
So in the work that you're doing, is it about explaining the decisions about what's good and what's not good in terms of the malware?
So it's about the decisions. It's about finding the. Okay, it's tricky. It's about statistical approach to finding the arguments. So we first statistically find the verdict. We've got the verdict, right? And then we are trying to play around with zillions of combinations of support arguments that are hidden in the data, and we test an experiment and statistically model and calculate and then find the minimal set of arguments which are in the data and are supporting the hypothesis.
Yeah, I'm going to try to unpick this again, because I'm not as quick as you. So you're recognizing that there is something bad, right? But you don't know exactly what it is that is causing you to recognize it as bad.
Yeah. So we have this file, right? And then we have lots of data about this file, where it came from, what it does, how it acts on these servers, what it does with the user, how it traveled. Lots of data about around this file. And then what we try to do is we try to kind of play around the combinations and try to hide some of the arguments, and then see whether the verdict would be the same if we hide those. And then we try to hide as many things as possible and still get the same answer.
So you're trying different combinations of things that make up this file, to work out which is the set of things that cause you problems.
Exactly, that are needed for causing the problem.
Very good. Okay, thank you. I understand. Now, explanations are interesting, and if I understand correctly, you're going to be generating these automatic explanations, which is fantastic. We'll understand, we'll be happy, we'll see why some messages are being blocked, and everything will be great. But can you not tamper with the explanations themselves? If we're talking about this world in which we have these adversaries who are going to try to be one step ahead of us, won't they be able to try to interfere with our explanations?
Yeah, definitely there will be adversarial examples in a similar way that they are currently manipulating these statistical verdicts. I totally believe that in a similar manner, the attackers will be super excited to deceive our system and to push the explanations that will be deceptive. And hence, it makes perfect sense to study those two problems together, the adversarial samples and explanations at the same time.
Okay. So, again, in this world in which we have these adversaries, and in which these explanations, I think, are being generated automatically, why do we want people in the loop at all? Why don't you said before that we weren't in any danger of in danger from machines. But actually, what you're saying is that people are going to be a weakness in this, right? If you want to keep up with what's going on, you need to make sure that not just that you have automatic explanations, but that you keep the person out of the loop, because if the human's in the loop, then we're going to slow everything down.
I actually believe that we are at a safe place when it comes to AI against AI. But until there is a person, we still kind of need to prove ourselves. And the person that is kind of behind attacks, this is the creativity on the other side. And it's not any longer the fight between man versus machine, right? It's man versus man. And it's only a fight who can harvest the kind of the potential of empowering your job through AI better, whether it's the attackers or whether it's the defenders. My senses say that currently the attackers do have a comfortable life because they can attack a lot, earn lots of money with rather simple stuff. Okay, so actually, I get my intuitions that there are more PhDs on the defender side than on the attacker side. But it may change.
So we're winning at the moment?
I think we are winning at the moment.
Okay. Now, you've talked about a number of different things. You've talked about neural networks. You've talked about explanation. You've talked about adversarial AI. What's the scope of AI? Because you've talked about 2 to 3 particular things. Can you say something about whether AI as a whole has more than that to help in this battle against the evil malware developers? Are there other things that we could be thinking about as well as those techniques that you've mentioned?
That's a great question. Yes. No. So what do you think?
So I'll tell you my view. I think that at the moment, people are talking about AI in the last few years, meaning generally deep learning or neural networks or a very small subset of the very large bag of technologies that AI brings. So you've talked about adversarial AI, you've talked about game theory. I think there are many more techniques that can be used. And I think what we're seeing at the moment is the use of things like neural networks and deep learning, because they're really good at doing a very small specific task. They're really good at pattern recognition, and they're really good at image recognition, and they might be really good at malware recognition, but as you've said, they can't explain things adequately, and they can't do a whole set of other things. I think when you started, you talked about reasoning, decision-making, and perception as being the 3 parts of AI. I see them being good at perception, not sure about reasoning. Decision-making, yes, in some cases, if the problem is well formed. So I see much more scope for using these different techniques, and I suspect we'll come to a little bit of a bottleneck very soon, where the techniques that we've been using up until now, which are really good at listening to your voice if you're using Alexa or Siri or some of these other things, will also want to do a little bit more. They won't want just to recognize some keywords. They'll want to be able to really have a discussion with you or an argument with you or something else.
Yeah, you're right. And this is, there was kind of the opening argument about the reasoning and knowledge-based AI, where Europe has got kind of more heads up comparing to other parts of the world. And I really agree with you there. I don't know whether you know that, but Ray Kurzweil, he said that by 2020, we will have a chatbot that will pass a Turing test. Later on, he kind of revised this, and he said it's going to be 2029. And he also made a bet with somebody, with Mitch Capor, on whether this is going to happen, and he bet $20,000. So, and also McKinsey, they suggested that by 2020 we will have 75% of chatbots passing Turing tests. So it's 2020.
So 2020, and when you say passing the Turing test, you mean machines that cannot be distinguished from humans, right?
Yeah.
If they're behind the screen, we won't be able to tell the difference.
That's what they say. It's not what I'm saying, right? But we are seeing the world of like large number of very unsophisticated chatbots And actually, I think that the number of unsophisticated chatbots will be growing faster than the world of these sophisticated chatbots. So I think that this prediction won't work. I don't know what this is, because all the chatbots are being trained on the scripts of communication, and the underlying technology is still statistical. There is not much of a reasoning modeling that are running those chatbots. This can be the evidence why there is a limit of the current statistical artificial intelligence for tasks like the chatbot. But I'm seeing also like lots of opportunity for combining reasoning-based AI which is based on modeling human reasoning and causality and inference together with statistical. And those algorithms that are being developed currently at DeepMind that are capable of playing Go and Shogun and poker combine these. They very much combine the capability of learning sophisticated game strategies, but from simulated executions that are reasoning-based, right? It's a combination of how your bot is playing reasoning-based, and you can improve it by statistics. So it's a nice combination how these two worlds can nicely work together.
Very good. I think it's very much how we work too. There are some things where we just recognize stuff, and there are some challenges where we have to sit and think and try to work out a good solution.
I was at the executive training, and they told me that the most amount of decisions that the executives are making are emotional anyway.
Ha!
To my huge surprise. Would you agree that? Because you are an executive. Are you making more of your decisions emotionally or rationally?
All of my decisions are extremely rational. Always, no matter what the provocation. Okay, let me ask something slightly different, because I think we've talked a little bit about issues around trust. Right? Explanation for me is a way for us to, as people, to have trust in what machines are doing, in the decisions that they're making. Let me ask a little bit about safety. You've talked about the decisions that your system's making, and you've talked about how things work in general, and you've talked about explanation as being helpful. You've also said that sometimes there are classifications, there are decisions that are not quite correct, right? That we might recognize a file as being malware when it's not really malware. And if you do that, then that means that we're going to suffer some negative consequences, right? We will be less efficient, less effective. So what we want is for these systems to take away the bad things, but not to take away the good things. Is it possible for these kinds of systems, whether it's in security, malware detection, or anything else, to provide some guarantees around the behavior to give us some safety? I mean, we've talked about trust so that we can feel comfortable in the world, but can we feel safe as well with some guarantees that AI systems aren't going to do bad things?
That's a delightful question. AI is complex and sometimes unfair because it embodies bias through learning on data that contains human bias, right? And there has been research in trying to remove it. It's very interesting, right? So to be able to remove things like gender or racial bias from the algorithm to make it better than the data on which the algorithm has been trained. So it's not about safety, but it's about kind of understanding and improving the quality of performance of AI. But your question was different. Your question was more into whether we can trust AI, whether it doesn't reach some unsafe state, whether it would always behave the way it should.
Can we guarantee some things about behavior?
And there has been like lots of foundational computer science research in trying to formally verify systems, even before they are programmed. It's a huge field and very successful. And lots of great people wrote fantastic papers in those fields. The trouble, though, is that the current AI is large scale. There's a huge scale of how our systems are operating, what is the with what size of data they work with, and it's more difficult to do this with the current scale of AI. So, and now comes an opinion of me as a practitioner of AI. I actually think that what we miss and what we will be seeing soon will be AI monitoring systems. If you're a bank and you got your systems, there are systems that monitor systems that tells you whether this website is up and running, right? It's very important for the whole industry to have the monitoring systems to give us visibility on whether the software systems in big companies are running or not. I truly believe that there will be like a new industry, new startups will come out and will be building the layers of software that will be monitoring how the algorithms are making decisions, whether the decisions are efficient, biased, anomalous, with a trend of some sort. They'll be inspecting AI automatically, and we will see our charts and our kind of the presentation layers on the screen, which tells me in my AI system everything works fine. So the monitoring is the piece that we don't currently have.
So, see if I get this right. So we're going to have our AI systems doing the things that they do, and then we're going to have another set of systems that are going to be watching the AI systems to tell us that the AI systems are doing the things they're supposed to do.
This is what we will have.
Okay, I got that in my head, that's fine. So do you think in that case that there's a need for regulation? Because there are lots of governments and public bodies that are considering whether AI is in need of regulation. I know that the House of Commons, the House of Lords have had AI committees examining what to do and what's important and so on. Do you think that regulation is also important, or do you think that we just need to trust these other machines to solve the problem for us?
So in this whole world of AI, data, internet, intelligence systems, so we see that regulation is important. And regulation is a mechanism how people can be better protected. And I actually think that in some AI businesses, some future AI businesses, we will see regulations as such. You need certain level of explainability for systems that run your business, or you need certain level of monitoring and keep reporting how efficient your AI systems work. So I think that if our society is regulating me how I am investing my pension savings, it's funny, right? My pension is funny. However, an AI system that will be running a healthcare institution and will be providing the diagnostics, will be telling what the trend is and what vaccine needs to be manufactured for the next year. This will be regulated. This won't be just a result of some data science experiment. This will be regulated. I believe so.
Let me ask one last question before opening up to the floor. You talked about Ray Kurzweil, who is a famous AI pioneer who's been predicting lots about the future, and you said that he was predicting that by 2020 we would have chatbots that passed the Turing test, that could pass themselves off as human effectively. What's your prediction for 20 years from now? It's an unfair question, but okay. Can you give at least one prediction for 20 years away?
Okay, so I'm much more down to earth. I'll give you a prediction for the next 10 years, right?
10 years, okay. I'll take it.
Okay, so actually, and it's simple. It's not very visionary. It's like really simple, right? I actually think that we won't be using that much of the smart watch and smart cell phone and smart earpods, but we'll be in big users of smart toilets. I actually believe that smart toilets will be a gadget for the next 10 years. Because we will need to collect the data about our health in the least invasive, most efficient, and very frequent, in the best case morning, right, way. So I'm a big believer in smart toilets.
Well, that's a fantastic way to end this part of the conversation. You heard it here first. Smart toilets in 10 years' time. And if you set up a company to exploit the smart toilet idea, he needs a 5% cut.
I would invest.
Okay, so we now are going to switch into taking some questions from the floor, if there are any questions. Oh, we have lots of questions. And I think we have a roving microphone. So there was one there, and then one over there in the stripy shirt, and then one just at the back.
Hello. Very interesting talk, thank you. I'm going to ask you a question which, if you can ignore the legal and moral parts of it and just stick to the AI. The Metropolitan Police announced last Friday that they will be deploying live facial recognition cameras on the streets of London, maybe outside or down there. So I was wondering if you're walking down the street and you walk past one of these cameras, what would you say or ask of the officers who will be in attendance at these cameras, and there'll be a feedback form apparently they're handing out. What would you write? What comment or question would you write? Again, speaking about the AI rather than the legal and the moral stuff.
So I'm not a Londoner. I think it's more a question for Mike, but before he answers, I'll give you my take. I was disappointed when I've learned that among the 10 cities around the world with the most face recognition cameras, there are only 2 that are not Chinese, and one of those is London, actually, right? So even before, London was known for this tech to be quite active. What's interesting is that it was mainly owned by private companies, unlike in China. I'm not a big fan because I'm lost. My labels are all over the internet as much as yours and most of you guys. But the labels, faces of my kids are not there, right? So my kids can still hide on the internet. So, and I think that, using a face rec is an invasion to human privacy. And I was pleasantly, when I've learned early last year that San Francisco was one of the first cities that banned it altogether. So the tech came from there, from California, and the civic society and even the entrepreneurs and the money, which is in San Francisco, banned it. So I'm for banning. I don't think it's a good idea. How about you, Mike?
I don't like the idea of facial recognition in the way that it might be used, as is being suggested. We have constraints on various other technologies and what might happen. Inevitably, as technology progresses, it tends to move ahead of our ability to understand the consequences, and we see that regularly. But we do know that people are paying attention. There are efforts to try to make sure we do sensible things, but it's a really important and very current issue.
Hi, Patrick Towell. I'm kind of horrified that it's 30 years ago that I was doing some work on truth maintenance and reasoning maintenance systems. So I'm making them multi-user, multi-agent rather. So is that the kind of stuff that you're talking about in terms of explanation that kind of stores networks of assertions and how they're associated and enable multiple reasoning engines to operate on a kind of shared data set, but where there could be some disagreement between those? And is that where that's going? And I know when I was doing that work before, I was thinking that in a way we should just treat humans as another kind of agent so that there could be a conversation between the AI and the humans in coming to joint decisions about, in this case, threats. And so do you see that happening?
So, okay, I'll start, and then, sure. you can help me, Mike. Right. So when I told you that I did my master's in AI in Edinburgh, I was doing proof planning and truth maintenance, right? So it was exactly what I used to love when I was a younger student, and it's fun. The limitation why there was a pause, a winter, in kind of doing more development in this field, I think, is the scalability, because AI became passionate for scale. So all the greatest practical applications of AI recently have been based on this large scale, and actually think that those models that I was studying myself 10 years ago were limited in terms of scaling up. However, the compute that is available today wasn't available 25 years ago, so for one, and second, the statistical AI wasn't as developed. So I really believe these days that time is coming for kind of doing more reasoning-based AI around statistical, because it's fun. We know it, we understand it, and Now we feel that we need it because of explainability. DARPA, for DARPA, explainability was a big priority even in 2016, I guess, like 4 years ago. It's nothing like new. DARPA knew that this is coming and they need to fund big programs in explainability.
So I think explanation can be understood in two ways. On the one hand, they are opaque, that are difficult to understand, which is some of the stuff that Michal was talking about earlier, right? You get neural networks, they come up with a decision, they say, yes, you can have a loan, you can buy, we'll give you a mortgage, you can buy a house, or no, you can't. And you need that to be explained somehow. The techniques that might be used at the moment, or the ones that are popular, that we've been talking, won't readily provide that. So explanation is a really important topic of research when it comes to those techniques that are difficult to understand. But your question is also about some other things, which is explanation of many other kinds of techniques. And what you've been talking about is explanation where you have different entities coming together to work something out. Just like we're discussing here today, we've got AI there, or real intelligence there, intelligence here, and we're working something out together by asking questions, by challenging, by rebutting. In fact, what we're doing is also a field of AI, Michal mentioned it earlier, computational argumentation. And that's essentially a logic-based form of doing just what we're doing, where someone proposes an argument, someone else says, that's not quite right, because I know this other fact about the world. So, yes, that is absolutely a current field of work. Yes, it's absolutely right that we need to deal with those kinds of issues. If you think about the medical field, where you have doctors with different specialisms, right? The same might be true computationally, where you have AI systems with different capability, with different knowledge bases, with different kinds of things, and they will need to come to a conclusion together. So, yes, typically that might be logic-based, like your truth maintenance systems. So explanation is really crucial in both of those areas. It's just that one is particularly more current at the moment because of the things like Alexa and Siri and image recognition and the things that Michal's talking about. Now, yes, this one down at the front, and we'll come back to the one at the back in a moment.
Thank you very much for the talk. You said that every day you get about 15 million new types of malware come into your company. How would the malware engineers be able to create this many different types?
So it's 50 million. We are blocking 50 million files every day, out of which 50 million existing malware, out of which there are 1 million new files that we see that we haven't seen before, which translates into hundreds of thousands of new malware. Okay, so the new stuff, which is on the market each day, is hundreds of millions of malware. So there are many malware writers, right? And even if each of the writers would write like 10 pieces of malware every day, which is not true, then it'd be like 10,000 malware writers. I think that there are less people writing malware. So as a result of which, lots of these files are even today generated automatically. And these are mainly the alterations, right? So for one, we call these families, right? So for one type of malware, there are like lots of different alterations, and these alterations are done automatically. Hence, it's kind of more easy. And because I've said before, small change in malware can evade current malware setup. So it's so easy, so cheap to create malware. So now we play the catch-up game. We want to kind of clear this up as quickly as possible. And our proposal is to be able to predict it, to move the kind of malware fight from reactive to predictive. Does it make sense? A big challenge.
There was a question over there at the back. Are there any more?
Yes, thanks for the talk. I just wanted to follow up on the question about when AI or whatever system is being used gets it wrong. In terms of your experience within the cybersecurity world, do you not expect to have a certain number of cases where it is getting it wrong? That is your sort of false positive rate, so you're blocking files, but actually, it's not malware, or it's not being blocked for a sort of legitimate reason. And how do you kind of balance it in terms of the more serious cases where you miss something that you should have blocked? And I was just curious how you kind of balance
Yeah.
those two?
So I can tell you how it's done today. So today, antivirus companies participate in benchmarks, and like third party is benchmarking all these software pages on the market, right? So and we are kind of being really benchmarked against the recall and the number of false positives, right? So and actually Avast is doing pretty well, but there are also others that are doing pretty well, and the number of misses is calculated in units, right? So given the size of the number of files that we see, so each month we miss 1 or 2 or 3, like really, really, really small, right? So which illustrates actually this whole world is fairly statistical, that statistically you are pretty much getting everything. So what would be interesting though is to kind of investigate, antivirus is in the consumer space, so we are protecting users, right? Like Cisco's or I don't know, like the other cybersecurity vendors, they are protecting enterprise. Our field is consumers, right? So and there it's more statistical because we have 500 million users. It's a huge population. It's more interesting in the government-to-government cybersecurity. It's more interesting in the enterprise cybersecurity, where the statistics has got totally different properties, right? And there, you don't see hundreds of thousands of new pieces of lethal malware being created every day. There are projects where like hundreds of people are working on one piece of malware that, and it takes months to develop, and then a long time to deploy, and then shut down a nuclear reactor. So it's totally different cybersecurity.
There were 2 on that row.
Thanks for the talk tonight. I was particularly intrigued by the use of game theory, maybe to kind of combat kind of malware application and development. So I was wondering if you could elaborate more on that.
Can you help me rephrase the question?
How do you use game theory to help combat malware?
Okay. So I said before that with the capability to evade adversarial samples, we are reducing efficacy. So we are less precise against the existing population of existing malware. So we give something for being predictive. We are less effective for the current. So we use game theory to be able to model the strategies of how much I want to be predictive versus how much the attackers want me to be predictive. This example, when in the past this one competitor was kind of playing with us and building the legitimate piece of files that we have classified as malware, it was an example. They wanted us to be less precise, right? And you will be kind of trading off the precision for current precision for predictability. And it's a setup of like a mixed strategy game, large-scale mixed strategy game, in which now we are experimenting with different approaches, different algorithms. We are experimenting with the double oracle algorithms that are kind of modeling this interaction and optimizing against something. So currently we are optimizing against the proportion of predictiveness and efficiency.
There, and then you next.
Thanks. Thank you very much for the talk. You talked about regulation earlier on, and I'm wondering whether or not there's an argument for combining regulation with ethics and requiring practitioners to have ethical standards that they signed up to, with concepts of do no harm, for example, and whether or not that's something that you would see happening in the future.
Yeah, so I totally subscribe to your point. I think that the regulation kind of goes hand in hand with ethics. Honestly, I see the whole world of AI from the ethical perspective into AI doing some reasoning, influencing our lives, and AI using some data. I kind of see this problem as kind of divided into 2 sets, and I'm more worried about the former one, about the AI using the right data, whether it's ethical to train on images, but it's ethical for the government to train the algorithms on the images from our IDs. Have the IDs been collected for training the classifiers? We're not, right? Do governments use it now for training classifiers? Obviously they do, right? I'm not saying it's not ethical, but I'm also saying that it is ethical. To me, this is like one example of an ethical debate. To me, much more exciting than the ethics of the MIT tram argument, whether the tram kills a kid or an older lady, right? So I don't think it's interesting. Interesting is what kind of data we get and how the data is being provided, who owns the data, who is being remunerated for the use of the data, and what kind of application the data enables, right? So for me, an interesting ethical question is whether in the future, whether the individual users of the internet will have more control about where their data are. Whether, and this is what I want to contribute as a scientist, whether we will have an opportunity in the future to pay for our services on the internet in a transparent way, to pay either with money or with data, right? So I wanna choose in the future whether I'll pay for Gmail. Gmail is a great service. I love Gmail. It's like really, really good. But I would much rather pay $100 a year for Gmail rather than with my data. I don't have this choice. That frustrates me. And so for me, it's another ethical aspect of AI, whether the AI was provided through the data or whether I will be paying for the piece of AI. Do you have any comments to ethics, Mike?
So first, there are already codes of practice. There have been for a long time for computing in general. To what extent people know about them, to what extent they comply with them is an open question. And I think the same will be true for AI. What's interesting is that there are lots and lots and lots of sets of principles and ethics that are being developed and published by large companies and by governments. And I think you have ethics on the one hand, absolutely crucial, that people should be doing things in a sensible, appropriate fashion. But if you want to guarantee what's happening, then you need to have regulation. Now, you wanted to come back.
There's currently no legal requirement or regulations to ensure that people who are practitioners have signed up to those ethical codes of practice.
That's exactly right. So ethics is a code of practice. It's a voluntary thing. They should be there. It's a good thing to do. We should think about it. Absolutely. Yeah, I think that's absolutely right. Regulation, if we want things to happen in a particular way, regulation may be necessary, but it's a very delicate question, and we're still very early in understanding exactly what the implications might be. But it's a really good question. There was a question over here.
Hi. Once we're going to roll out automated cars and IoT systems and cities will be full with sensors, I suppose a lot of malware will start popping up. Is Avast considering predicting anything in the automated car, for the automated car industry or for smart cities, smart houses, or even smart toilets, as you mentioned?
So thank you for the question. Avast is not actually currently thinking about doing anything in automated driving and car-to-car communications, but Avast have made in the past a huge bet on IoT as such. And Avast really believes that the future carrier of malware will be the IoT devices, because currently it's much easier to hack a printer than anything else, right? It's easy. It's so easy. And if you are at a law firm and you would like to exfiltrate data, doing that through a printer is the most straightforward way. It's easier than hacking like an email account. And there are IoT devices, you cannot check them all. There are way too many, way too diverse. So many are so old. It's a huge legacy problem, IoT devices. Huge. And for example, we work with Stanford University with Professor Zakir Dumerik, and he's an expert in being able to measure. And he's measuring for us, for Avast, how many IoT devices are there, how they look like, who is using them, how they are protected, whether they have some protection. And we were thinking in Avast, how to work around this problem. What is the starting point? And we felt that the most important is the household, right? Because the number of smart devices in households are growing much faster than in the enterprises. So we have built a device, like a small router, Omni device, that you put at home and you plug into your router, and it automatically identifies what is going on at home, what devices you have, whether they are patched, whether they are in some anomalous status, whether somebody is streaming video out of your home. You just don't want this, right? You want to see that there is a video stream going out of your house. So this is where we are doing lots of research, and we are kind of one of the leaders when it comes to IoT security. For us, it's a big investment because users are currently buying other things, right? Than investing in IoT security, but we see the future, and we think that this field will be huge, and we are getting properly ready for this.
There's a question here.
So firstly, thank you for the talk. It was very interesting. But you spoke about how, like nowadays, more and more of like cybersecurity, like attacks and defense, is becoming automated by machine learning and AI. Do you believe there might be like a point where it's more AI than human, or just completely AI? And if so, what would like the humans do at that point in those kind of jobs? What would it transfer to?
This is a super exciting question, and believe me or not, I'm spending lots of my time thinking about this, actually. And I don't have an answer. I want to please you with like a sophisticated answer. But so far, we are betting on somebody having the idea, right? In the cyber world, the attackers do have ideas. I don't want to kind of be under attack in the evening, but I would like to say that these ideas are not so sophisticated. They're still simple. They're still brute force. The most of the attacks are brute force. Kind of write simple malware and just spread it and see what I can get, right? I think that the trend that we will see is that there'll be less of these, and there'll be more of the targeted, sophisticated. I want you, or I want you, because I know that you are from a rich family, or because you are vulnerable. So your malware will be choosing, and there'll be like more AI, but still run by people. I haven't figured out the argument or this inflection point why the creativity from the attacker side would go away. I don't think that the machines would need to want money for themselves. They don't. If they need something, this may be energy. They would start switching off your air conditioning because they want compute, right? This may happen. By the way, the amount of Bitcoin transactions around the world is eating as much energy as the Czech Republic total, or as an Ireland total, right? So imagine another Bitcoin something, right? And we may be short of energy. So if AI needs something, it needs energy.
Thank you.
There's one here, and then there's one at the front.
Hi, just a basic malware question. You obviously have a great perspective and visibility of what's going on. I was just curious what methods of attack people are using, how you see that changing. For example, is it attacking browsers, phishing, etc., or other things?
So you're asking about the defense or the attackers?
The attackers, what mechanisms they're using and how that's changing over time.
So it depends what type of malware you are investigating, right? So it's difficult to kind of provide like an overarching analysis of what are the trends, right? So we are seeing interesting trends, for example, in packing malware and packing the triggering conditions in malware as a neural network. So like one of the interesting trends recently that we saw was in the software that helps with images, that often is full of like some neural networks or some classifiers that are statistical, that are very difficult to explain, right? And one of those becomes a triggering function, right? It's very difficult to reverse engineer a piece of a neural network, which is why we are seeing a trend that the attackers are hiding the triggering conditions into neural networks. That's one of the interesting pieces that we saw. As an example.
And then one here at the front.
Hello. So, thank you for the amazing talk, but I'd like to know how much will AI be able to automate penetration testing? So, say, trying to exploit a system so you then know where its vulnerabilities are so you can patch them?
Yes, it's a great question, and it is a huge area for use of AI these days, because pen testers are very expensive, and we don't have many of these. And AI systems currently are doing a lot of pen testing, and it will be even more exciting in the future. There have been research projects where people are trying to predict vulnerabilities. There are like code repositories around the world where people are putting errors and malfunctions in code that in a way can become a data for projections of the vulnerabilities for systems. And people are speculating that these can be leads to be able to predict what the future malware would look like. So pen testing is a great field, and it's getting very automated.
Okay, thank you.
We have one more question over there.
Thanks for the speak, very interesting. Are you seeing any evidence of people sort of planting seeds in open source code, in large repositories, etc., that could later be exploited by sort of interconnecting them all together?
That's a great question. We were debating that in the past. We are not seeing. Are you? I would be interested, because this is debated quite often.
Is there any last question or two?
I was just interested when you were talking about people's trust and needing to understand how something works. When you start to talk about machines making decisions for us, and I did it a few years ago. I shot a film in America for Google for their Waymo self-driving car, and it was exactly as they wanted to make something that explained a bit how it worked and the sensors and all that kind of thing. And what was interesting about it is we made this film, and at the end of it, they said, "Do you want to go for a ride in the car? We'll put it in the kind of drive mode." And we drove across Phoenix in the car, in its automatic mode. And literally by the end of a half-hour drive across Phoenix in the rush hour, I'd sort of completely stopped worrying about my safety or anything, become completely relaxed that this car was going to, there was someone there with an emergency stop button, but basically it was very quick from getting into it and actually becoming totally trusting of it. And I think, and I didn't really know how it worked, of course, and I just thought that actually those things, you quite quickly can get used to them. And I think a lot of that stuff people would get used to quite quickly and not need to really understand it that much. I think once you do a couple of rides, you go, it works. And it's fine. So I just thought that the question of whether people really do need to understand those things to make decisions, you're talking about medical decisions and things like that. And I wonder how much that is the case, or how much people will just, once it starts happening, people will just get used to it.
Yeah, I like this question very much. Some people are comparing autonomous car to a lift, right? So we are totally okay with the lift. We don't need to understand it, and we use it. And it was kind of the note I've made early on that car is full of non-explainable AI, and it will always be like this. So we will never learn why exactly camera sees this shade the way it sees. It just sees it this way, and we kind of miss this train. We will not get any more explainability on the camera on the car, and we will be driving the car, right? So actually, I think that your car is the use case that will be the last big unexplainable use case that we will get used to. I actually believe so. The explainability that I'm talking about is the one which will be in healthcare and maybe education and media and all those kind of really application areas that badly influence the society. And actually, I think that explainability is very much related to future job market. When I got this recent interview when people were asking me, what will be the future jobs, right? So some jobs will go away and new jobs will come, and what they will be like. I said, you know what, I don't know. But when they ask me what the job skills of the future in the market will be, I'm sure that there'll be like one very strong job skill that will be asked for, and this is empathy. Empathy towards people and people towards machines. The empathy that we will be more understanding machines, that we will be able to work with them better, we will be able to take the benefits of what they do for us better, will make people on the job market more efficient, more successful, right? So I think that those who will understand machines will have better opportunity to take more benefit from AI, but also be more creative, be more critical thinkers, and be those who will be inventing new things. Who will be the human of the future will be the human that will be inventing new things. They'll be creative, right? Actually, I think you're either creative or working for people. These are the two kind of job lines I'll see in the future. Not people working for machines or for numbers or for money, but people working for so that they create, they innovate, and people who work for people, right? People to people, this new people to people economy. I don't believe in robotic nurses. I don't think it will be only in poor countries. Rich countries will have human nurses. Poor countries will have robotic nurses.
So I'm going to end with a question of my own, which I'm going to ask all of you. I'd like hands for this one. And that is, how many of you think that we should be worried that rather than give our trust to machines that are self-driving, we should be concerned to make sure there are these things like explanation and guarantees and so on? And how many of you think that actually it will be fine, we'll just get on with it? So if you're worried about AI, if you're concerned to make sure that we have the right checks and balances, that we have regulation and ethics, that we have explanation and so on, raise your hand now. And how many of you think, actually, we're going to be fine, it will be all right? Oh, I think it's a very clear answer there. Thank you all very much for your questions, which were absolutely brilliant. Thank you.
Thank you.